Just a minute. Hello, welcome to the Godless Family Webcast. I'm your host, Aubrey Adrianson, and tonight we're talking to Dr. Dave Hawkes about viral therapy. And so with us tonight is Dave and my co-host, Amanda Hayes. Say hello, Amanda.
Hi.
And we're going to have Dave introduce himself and tell us a little bit about himself. So take it away, Dave.
Hi. It's good evening to everyone here. It's about 11 a.m. here in sunny Australia. I'm actually a virologist, so I did a PhD on HIV, and now I work at making viral vectors to understand how our brain works in terms of anxiety, depression, fear, and I also work on projects to do with epilepsy, multiple sclerosis, and a few other bits and pieces.
Great. So Dave is our go-to guy on this topic tonight. And I chose this topic because I saw an article, which is one of the pre-discussion readings about viruses being used to fight bacterial infections in Russia. And I found that fascinating, and I started talking to Dave about it, and Dave said, well, let's do a show on it. And so first, I want to just have Dave tell us, well, what is viral therapy in its various forms?
Okay, so when everyone thinks about viral therapy, they think about viruses. So the most common viruses most people know are the flu, HIV, herpes, hepatitis, a few other things like that. So these are viruses which are small, very small sort of particles or sort of little organisms that can infect cells and cause disease. Viral therapies are based on what we call viral vectors. Now, it sounds like it's being a bit of a pedant, but a viral vector and a virus are slightly different, but in one major way. A viral vector can't replicate. So you can put in 1,000 viral vectors into an animal, a human, cell culture, whatever you want, and the most you will ever have is that 1,000. From the moment they're injected, they get smaller in number. Whereas if you put one HIV particle in a person, that can create more and more and more, and thousands, hundreds of thousands, millions of viruses. So viral vectors can't cause disease. A lot of people are going, well, why are we using viruses? Like, you know, viruses have been in the news lately because of an Ebola outbreak, and that sort of is a bit scary because viruses are generally bad. But what viruses are really good at is getting their genetic material into cells. Human viruses are obviously very good at getting into human cells. Now, if we want to get DNA into cells in a human being, we can use stem cells, we can use some liposomes, we can put the DNA directly, but it's less efficient. A virus is been evolved over millions of years to do one thing, and that's get its DNA into the cell where it can replicate. So these viral vectors, we have sort of our Ebola virus, and it's got a little bit of DNA or RNA in the middle of it, and it gets into the cell and creates more proteins. Viral vectors can't create viral proteins. They'll only create the proteins we want. Now, I know this is getting a bit boring, but what we can do is we can, at the simplest level, we can get a virus and we can make human cells glow green. And so the virus will get into the cell, and all it does is it makes a green protein. That's it. It creates no more viruses. It does nothing more than make the cell glow green. And this has actually been used in art projects. There was an artist in New York who used similar technology to make a rabbit glow green in the dark, and that was considered modern art. We call it a bad day at the office. So hopefully that has given at least a bit of background onto them.
Right.
But
keep going if you want. If you keep going.
Sorry.
Oh, I'm sorry. I'm trying not to interrupt.
No, interrupt. There's a slight delay, but hopefully we'll pick it up. So you want to get DNA into cells, and you kind of go, why? And you're sort of about viral therapies and gene therapies. Now, most people are familiar with genetic diseases. So things like cystic fibrosis is probably the most well-known. People have a deletion in a particular gene, and it means that their body doesn't create these particular ion channels, which means they have problem digesting food and extra mucus in the lung, and their life expectancy is much lower. But theoretically, if you replace that gene with a good gene, they would be fixed. There's nothing else. You don't need to do anything else lifelong. You just need to fix that gene and we're done. We haven't been able to do it as yet, but I think there's several hundred different clinical trials using viral vectors to introduce DNA, and while some genetic diseases are part of them, they're also for cancer. So if you can get a virus that will attack cancer cells or make your own body attack the cancer cells, that provides quite a good treatment. So there's a new viral treatment that's available in a clinic in Europe. So it's no longer imaginary, it's actually into the clinic. And it's called Glybera, and it attacks a particular genetic disease which causes inflammation of the pancreas. And you need one dose. That's it, one dose. It costs estimated $1.6 million for that dose. So it's not cheap, but since this is the first one, the first personal computer was very dear, and I imagine prices will go down over time. So I'm going to take a breath and try and answer any questions.
So the next question, you've kind of already hinted to that, or started working on that, or what are some of the ways these viral vectors are used? And so you mentioned treating genetic conditions and cancer, and then there was the article about treating bacteria. Is there anything else?
I guess it's sort of
bacteria. Like... Sorry.
Yeah, I mean, your immune system is very good at fighting off diseases, but sometimes it misses them. With HIV, your immune system and HIV are a really bad combination, but there's actually a case. They've turned it into a video. They made a little movie about it called Fighting Fire with Fire. It's available on YouTube, where they took the immune cells out of a girl who was 8 who had leukemia, I think, for the 3rd time, and was pretty much going to die. And they took these cells and they used a virus to change the cells, and they turned these T cells into what the rather artistically decide to call serial killer T cells. And they put those cells back into the girl's body. So it was the girl's own cells into her body that had been reprogrammed to attack the leukemia. And she got a fever and she got really sick for a couple of days, and then she started to get better. And that shows that, and as far as I know, a couple of years later, she's still in remission, and it seems to have worked. So if you can train it to attack cancer cells, you can train it to attack bacterial cells that maybe are not available to be targeted by antibiotics, or even other viruses. I mean, they're using certain viral vectors to target cells to target the HIV virus, and that gets quite complicated, but you're using viruses to fight viruses. And anything you can think of doing in the body, you can do with a virus. So at the moment, the sky's the limit. There's people looking at using viral vectors to combat epilepsy, because we know that certain proteins are down-regulated in certain types of epilepsy. So if you cause the body to make more proteins in that area of the brain, you can actually reduce the seizures. So yeah, pretty much, if you can think of it, we can do it with a virus.
Cool. So one of the things Amanda and I were talking pre-show is talking about the difference between bacteria and viruses that some people might, I'm sure many of our listeners probably know the difference, but it is a common misunderstanding. So if you could just kind of explain that for us, since we are talking about using viruses to kill bacteria.
For sure. Essentially, viruses and bacteria are the two biggest pathogens people think about that cause disease in humans. So if you look at, say, the whooping cough bacteria, it's probably one of the most common people would have heard of. There's been outbreaks in California in the last few years. And the whooping cough bacteria it's a living creature. It has about 3,000, creates about 3,000 proteins, different types of proteins, and you can leave it outside and it will give it some food and it will grow, and it will divide, and it will do what it wants to do. And you can see bacteria under a microscope. So you're looking at things that, some bacteria are millimeters long, some are parts of a millimeter long, but you can look at them under a microscope. Viruses are much, much smaller. There's a bit of a debate over whether they're alive, because when you have a virus in a tube, it can't make more viruses, it can't replicate. It needs a cell to replicate. So that's a difference. It can't replicate on itself, and it's generally pretty fragile. If you leave some HAV on the bench overnight, by the time you come in, say 12 hours later in the morning, because scientists work 12 hours a day, you will have lost, it will be about 1/1,000,000th as infectious, maybe less. So it dies pretty quickly. And HIV, it's one of those things. I think it has 12 proteins. So 12 proteins in HIV virus. There's less in other viruses, the more in others, versus 3,000 for a bacteria. So a virus is also very unique. So what works with HIV as a treatment won't work with hepatitis, won't work with influenza, won't work with other viruses, whereas antibiotics target the cell wall of a bacteria. And bacteria, there might be billions of different types, but they all have pretty similar walls. So if you can target one bacteria, you can target thousands. There's very few antiviral drugs. So we know about HIV drugs, pretty well known, highly active retroviral therapies. You've probably heard of there's Tamiflu, is not a great dog for targeting influenza. There's a few others, but really not too many, because each individual virus needs a brand new drug targeted to it specifically, whereas antibiotics will target pretty much all bacteria unless they've developed antibiotic resistance or some other workaround. So essentially viruses are tiny, beautiful, elegant, and bacteria is like the linebacker of the pathogen world.
But we can use the viral and the gene therapy to kind of fight both of those. Is that what you're saying? Like we can start small with the viral therapy to take care of some of the typical, like you said, influenza, as well as the gene therapy to work toward like the big genetic diseases?
Absolutely, because viruses are so simple, we can understand them much better because they don't actually need, most of the things they need to replicate are in your own human cell. So we don't need to mess around. We can actually, when we make a viral vector, there is no HIV genes left in it. None. Zero. So we have no chance of it. We know exactly what it's going to do because it can't grow by itself. It can't do anything by itself. Whereas a bacteria kind of goes rogue and it can evolve because it's replicating itself, whereas a viral vector can't evolve because it has no genetic material. So we can use this to target bacteria, anything, because it's so simple, we can actually understand it, and therefore we can modify it. Now, we can't treat HIV yet. We can't treat other different viruses because while we know what's happening, once it's in the human, it can evolve, and these things replicate every 24 hours, and they just change so rapidly. And I've spoken about viral evolution quite a lot in the last year. But when we modify them, they don't have any of that, so they cease to become, different. Whereas a bacteria, anyone who's worked in a bakery knows that yeast can get into your hair and it can give you infections and things like that, because although we know how to use yeast for baking, it can also go rogue if it gets caught in our hair or our clothes or anything. We had an honours student who had real problems with her cell cultures dying constantly, and we worked out she had a part-time job at a bakery and was bringing all this yeast in that was contaminating her cell cultures. So viruses are much more controllable and much more modifiable with what we know now, whereas bacteria is so complex, can grow on their own. They're more likely to evolve in such a way that actually makes them dangerous.
Wow.
So one of the things I was thinking of when I was researching this topic was the day that I would walk into the doctor's office with like an ear infection, and my doctor says to me, well, we're just going to inject you with this virus and make this infection go away. So do you see that as the future of medicine?
I don't necessarily see an ear infection as the future of viruses, because we can deal with infections pretty well at the moment with ear infections. We have pretty good treatments. We don't need to reinvent the wheel. But you look at, there's a huge amount of genetic conditions that affect people, so it could be sort of the really severe, obvious ones like cystic fibrosis or haemophilia. These are obviously change your life, and if we can fix them with a single gene therapy, that would be fantastic. But there's other ones, like, everyone has, if you're, breast cancer gene, we know it only accounts for 5% of breast cancers, but there's such a strong link between that one gene and your chance of getting breast cancer, that if we can fix that gene, then you go from, what Angelina Jolie has chosen to, which, double mastectomy, and what's really quite severe surgery, and is obviously going to affect your personal view of yourself, to using a viral vector to change that gene so that you don't have that propensity to get breast cancer anymore. We can use the viruses to target the other thing that's beautiful about them is that if you have, say, a lung cancer, or you have certain lung conditions, we can get you to breathe in a virus that will only target certain types of lung cells and act on them. And the specificity of a virus, like I work on the brain, so I can put a virus into a region of the brain that might have 10,000 cells. And because of some modifications I can do, it will only actually infect maybe 1,000 of them. And it will only therefore modify 1,000 of them. So we can, instead of antibiotics or surgery, which are very broad, we can target this down to a handful of cells if that's what's needed. So the ear infection, we can kind of deal with at the moment. Very few people die of an ear infection. Well, maybe with some of the healthcare available in the States they might, but in Australia, where we've got socialised medicine, which is apparently a bad thing, no one really dies of ear infections. But
I was just thinking for more common, something really quite common. Are we going to see this coming up?
Yeah, that's what I was kind of going to ask too, because it sounds like you're saying that the future of it is more into the gene, the gene manipulation and the gene therapy. But in the article that we read before the show, one of them was talking about treating really common infections with viral therapy because of the antibiotics doing so poorly with the common bugs kind of evolving.
And I guess that's the key point, is like an ear infection that can be treated with common antibiotics is not the target, but because viruses carry risks, like any treatment and any drug, with the viruses there is a very small chance that they could lead to cancer. Now this chance has been going down further and further and further as we've modified the viruses. Like I've been working on these for 10 years, and in that time it's light years ahead of where it was. And so in terms of, if you've got an easy, quick way to treat something, you'll do that. If you have an antibiotic-resistant bacteria, your options are live with it or die with it, or getting a viral treatment. A viral treatment is obviously much more attractive. If you have an ear infection that will clear up by itself, the risk of getting cancer, while tiny, is higher than the risk of the ear infection causing problems, whereas once you get antibiotic-resistant bacteria, this is becoming a killer. And so this is something where it can do. And the brilliant thing about a virus is if we decide on, say, Monday the 1st of January, that we've got this new antibiotic-resistant bacteria, theoretically, we can have a new viral vector out by the 1st of February.
Wow. So
it won't be tested, but in terms of actually cloning, creating, and checking that we've got enough of it, that's how quick this can occur. So compared to, say, drug, and because with a virus, 99% of it will say exactly the same. You'll change the gene you're targeting, and that's it. So you'll change one gene, and you've got a whole new range of treatment options. So, yeah, I don't think it's going to be that, yep, you go to the doctor, okay, we'll give you the virus for an ear infection, but viral vectors for vaccines are being developed. Because there's already they use viruses which have no genetic material. They use the shell of it to induce immune, and that's great. And things like the HPV vaccine is that type of virus, that type of vaccine, but using viral vectors also. And so in terms of going to the doctor and getting one, in terms of vaccines, you will be in the near future. In terms of like arthritis is another one that I think the viral vectors could be quite useful for. Infections, it's always going to be a really difficult thing to nail down because it will be on a case-by-case basis. But a lot of the things that you talking about heart disease, they're looking at viral vectors to reduce inflammation, which is one of the main causes of heart disease. And pretty much anything that kind of can go on and sort of cause you problems is someone's probably looking into it right now.
So this situation came up, gosh, how old is my daughter? I think maybe she was 3, maybe 4, but she had a lot of recurrent bladder infections, and the doctors couldn't figure out why she was getting these. And each time, of course, they're worse and closer together. And so the last one that she got, she did end up, the bacteria did end up being antibiotic resistant. And they had to give her, I don't even remember what it's called, but with insurance, I had to pay $60 for this antibiotic. And I was complaining about it, of course. And the doctor said, well, if it's the strongest one I can give her that won't cause damage to her body as a young person. And I was just blown away, like, oh, we're at that place now. I had no idea. And so when you said, started talking about antibiotic-resistant bacteria, that's where my mind went, is that situation where we're having to figure out what was happening with her body and why she was getting these horrible, horrible bladder infections with basically some super bacteria in her body. And I wonder if in the future a viral vector would be something that you would give instead of these antibiotics that actually harm your body as well as harm the bacteria.
Yeah, I mean, I got into medical research because I actually got an ear infection, strangely enough, that nearly killed me. It was a very rare 1 in 11 in Australia ever got it. And I think I was one of the first ones to live, and I only got through because of an experimental antibiotic, which I think was costing $12,000 a month.
Wow.
Wow.
But because of socialized medicine, it cost my family $0. And so thanks to that, I survived, and I was in hospital in 4 months, over, I think, 15 months. And so I think antibiotics are fantastic, but the speed at which we can develop them is slower than the speed at which antibiotic-resistant bugs are coming. And what they're doing now is because not only have treatments changed, but diagnosis have changed. Like, I've got friends in a lot of other fields in medical research, and what they would do, I would imagine, is to take a sample of the bacteria. And now we can sequence the whole bacteria in an afternoon, and they would find out what it is. They would also find out what antibiotics it could be resistant to, and then that would open up to, okay, well, the antibiotics we can use have side effects. Like, the side effect of my antibiotic is it has a propensity to cause spontaneous tendon rupture.
Oh my gosh.
Wow.
That's
if it's either that or die, then I guess.
Yeah.
Oh, yeah. Now, I've had a long history of tendon injuries since then. I was 13 when this happened, but my wife says, I'm not sure you can blame the antibiotic. I think you're just quite uncoordinated. But you look at those things, and I look back and I go, well, has this played a role? Because I've never really had any other injuries other than tendon, but it could be a number of things into it. So you're looking at side effects of antibiotics, and again, as you said, death versus tendon rupture, I know which one I'll take. But with a viral vector, as I said, if you can sequence the bug, you can know where its weaknesses are. There is the ability to be able to pick and choose a viral vector to target them. And because the speed at which they can be developed, because any new antibiotic, they have to work out the structure of it. Will it change structure? I mean, thalidomide was, the issue was, if you imagine a molecule, and you're looking at a clock. So imagine the atoms on the end were in an order of, so they were at 12, 4, and 8. With thalidomide, it went the other way. It went 12, 8, and 4. And so because they were in the wrong order, which is actually still thalidomide, it's just the slightly different structure of it, it was one of those that actually caused these horrendous birth defects. And so you've got to work out where every molecule is, not how many molecules are in it, but exactly what order they are, what crystal structure, what they'll interact with. Will this antibiotic interact with another protein which will cause a size effect, or all these different things? Whereas with a virus, 99% of it will be identical. We know what the viral proteins do in terms of an immune response. We know all the other bits and pieces we put in there. We know what they do. If you're changing one gene, that's going to speed up development because you already know that the package you're putting in is safe and you're just changing one little bit of the DNA. And so that allows you to, they can test, and if they see things starting to occur, if they see that, you know, there is a new strain of antibiotic-resistant bacteria coming up in, say, you know, the Midwest of the States or southern China or northern Africa, they can go, all right, what's causing this? Let's work it out. Let's look at what we've got. Okay, this is what it is. And if you've already got viral therapies out there and being used, they can modify one that's in, test it, and then actually be able to be more proactive in targeting those things rather than an antibiotic will take a hell of a lot longer to develop.
We have a question from Kyra. Do you think there's any truth to the claim that drug-resistant illnesses are developing because people are not taking the full course of their prescribed medicine?
In terms of the full course of their prescribed medicine, it's difficult to say. The thing is, it's overuse of antibiotics. So whether it's taking the full course or whether it's people having antibiotics for things they don't need them. If you have a bug that's causing disease and you have the antibiotics and you take it for the 2 weeks and it kills all those bugs, fantastic. If you take it for 1 week and it kills all those bugs, that's great. But you only need one to escape that has, you know, a little bit of protection against the antibiotics. And then that can grow and grow. Then you have more antibiotics. Then it selects for the better and better and better and better. And gradually you end up with those bugs. So when people are taking antibiotics when they have the flu, because antibiotics don't work on viruses, I really need to stress that, then you will actually develop bacteria in your body that is antibiotic resistant. Now, some of those bacteria will be in your gut and they'll eat your food and it won't really make any difference. Some of them could be bacteria that can cause disease, so then you suddenly start getting a cough and it won't respond to antibiotics, and that's because it's sort of slowly over months or even years in your body been optimized. It's a performance car. It's gone from being a Volkswagen Bug up to a Corvette. I'm trying to speak American here. Up to a Corvette.
Because I've got both of those in my driveway.
Yeah, absolutely.
We're in Australia, we only have 2 types of cars. We've got Holdens and we've got Fords, and when you're born you choose one or the other and then you never sway from it. And you know, wars have been fought about this. We're not big on religion, so we have to sort of find our arguments where we can. So in terms of not taking the course of the antibiotics, it doesn't help. There's no benefit to not taking them. If you take them, the chances are you'll actually destroy more of the bacteria. You're less likely also to pass it on to anyone you know. So I would say always take the full course of the antibiotics. And yeah, I can't say definitely it's causing antibiotic resistance, but it's certainly not helping it. So yeah.
I'm glad you brought that up because that was something that I was kind of looking up too when I was talking to my friend about it beforehand, because he's like, we've got this antibiotic crisis, you need to look it up, where, you know, these things are becoming more and more drug resistant and it's going to change the face of modern medicine and, you know, the end of the world. And so that was one of the contributing factors to it, was people overusing them for things that they don't even work on, you know, going to the doctor and just insisting on getting these antibiotics, despite them not actually helping and getting rid of, you know, the infection you have or the virus. And then people not taking them for the entire time, and that one, you know, that one rogue, you know, cell getting away and then being able to mutate so that it's resistant against the antibiotic next time, which I thought was funny because, you know, when I was growing up, my mom had always said that, like, if I got, you know, strep throat, you need to take these for the full 2 weeks. You know, I was like, whatever, I'm feeling better, you know, and she didn't really have any good reason for it. She just told me that I need to do it, and so I was like, you don't know what you're talking about. And so now knowing this concrete reason that I can tell my kids, I think is really amazing.
The best example I can give of that is cold sores. if you've got a cold sore, pretty much you get cold sores for your entire life. If you've never had a cold sore, you don't get cold sores. It's due to the herpes virus. So the cold sores is like the coughing and spluttering of having a disease. You can get rid of that with medications, but the disease will still be there. The pathogen that causes the disease will still survive. So if you take your antibiotics, it stops the disease causing your cough, but the bacteria might be killed down to, say, 30%, where they don't cause disease, but they're still alive. With a cold sore, you can take treatments that will get rid of the cold sore, but it doesn't stop the underlying pathogen. It doesn't get rid of the virus. It really has not too much effect on the virus. It just stops the visible cause of that illness, but the actual root cause of it doesn't change. Like, people who take blood pressure medication to, thin their blood, doesn't mean their arteries are any less clogged, but it just means that the blood is thinner so it can flow easier. So there's a difference between what the disease is, what we actually see, so it's a cough when you're sick or a sore throat, and what actually causes it. And they're two different things, and people get rid of the sore throat. They go, and stop taking it. But the underlying bacteria is still there. Now, the bacteria might kind of have had its day and not cause another sore throat, but you'll pass that on to someone else. And when they have the antibiotics, they may not get rid of that sore throat, or it may take longer, and that's sort of how it goes along. My son already has a couple of stuffed different viruses. He's 8 months old, that he plays with. He's got, I think, the HPV virus and the hepatitis C virus, and so
that's so awesome.
He's also got a neuron.
I'm going to ask a question that's off topic. I know we're kind of getting off topic a little bit, but I wanted to know that one of the things that's coming up a lot when we talk about the overuse of antibiotics in America is factory farming, and basically the cows and pigs and chickens are just automatically being given an antibiotic to stop any illnesses that may occur from being in extremely close quarters and being unable to move, and so that's one of the things that is being talked about a lot here, and I just wanted to know, do you have anything like that going on in Australia?
I will start by saying this is outside my area of expertise, so this is stuff that I have sort of a layman's knowledge, but in Australia we have much stricter rules than you do in the US. So we have quite a different attitude to that. So we have 2 major supermarket chains, and one of them has all chicken has to be free range. Free range eggs, so not battery and not cage hens, have to be clearly marked on the packet, and a lot of the brands stocked by these supermarkets are free range, and so that's sort of with the chicken things in terms of pretty much all the meat in at least one of them, if not both of them, is hormone free, so we don't have any hormones given to that. In terms of antibiotics, I think there's actually really strict rules on whether or not you can use antibiotics, but Australia is also a little bit different because for some people, we're an island. We're a very big island. Our island is bigger than the continental United States, but we're still an island, so we don't have foot and mouth disease. We don't have anthrax. We don't have American football. So we want to keep these things out of the country as much as we can.
Oh, gosh.
I just want to know what your restrictions were, because it popped in my head, and I know it's completely off topic and not at all what I asked you to come onto the show for.
Oh yeah, I mean, we have very, very strict rules on animal farming and different things than you do in the States, because we have a very different agricultural system than you do in the States. Like, we don't have the subsidy system in anywhere near the sort of level that you have there in the US. Our parliament is run quite differently, and so we don't have the different states getting sort of different benefits from the federal government than you do. Like my understanding of American politics, if you have a powerful senator who's from a state that grows corn, the federal government will give big corn subsidies.
That's pretty much how it works. That's my
Yeah, I was
understanding
going to
of it.
say, it sounds so corrupt when you put it in layman's terms like that, but I can't deny it. That's kind of what's going on.
Yeah, so we have a very strong agricultural lobby, and we, in Australia, near where I'm in Melbourne, we built a $600 million building about 15 years ago to specifically study foot and mouth disease so that if it came to Australia, we'd be able to fight it. But the Farmers Federation of Australia is so powerful, they were never actually allowed to bring that virus into Australia. So we had a $600 million building that they decided to play with other viruses. And if you've seen the movie Contagion, they actually refer to that building because they do some of the most cutting-edge viral work in the world because they've got a fantastic facility. But yeah, we have very different rules and a different political system, and I think that has actually changed it because people will sort of say, yeah, we don't want, like there's, to do with milk production, there's a different separation, and it creates, you separate the milk and then you mix it back out, and it's called permeate. It's essentially exactly the same milk. There's no hormones or anything, but it became a thing about a year or two ago, and Australians said, we don't want permeate in our milk. And then suddenly because two supermarkets control 80 or 90% of the milk in Australia, suddenly all the milk was going, yeah, we're permeate free. And it happened in the space of months, and then suddenly it was permeate free. There's been some stuff about animal slaughtering, and so there's been new laws induced to be more humane. There's big spot checks. Abattoirs have been shut down quite regularly for inhumane practices. So we're probably much harsher, much stricter on sort of antibiotic use and all these things. So it's not so much of an issue here. So yeah, when the apocalypse comes, we've got sunshine, surfboards, and antibiotic-free meat.
That's awesome. I hate to keep going about antibiotics. I'm so sorry. But I just have to share, like, when we're talking about overuse of it, because for a while my parents didn't have health insurance. And so any getting sick or you know, infections or viruses, they couldn't go to the doctor, or we couldn't unless it was really, really serious. And so they were like always looking for ways to fight stuff at home. And so amoxicillin obviously is a great antibiotic for fighting things. And I just remember my grandmother used to go down to Mexico, and she would stock up on amoxicillin from Mexico because we couldn't afford it. And every time she came back, she was like, I have all this amoxicillin. You're going to be fine. It was just like, oh my gosh. Just looking back on it, I'm like, why did they do that? That was such a terrible idea. Wow. But like back then, it was like a godsend, you know.
Yeah, in coming from someone who's really interested in health, that really breaks my heart, because in Australia, if I didn't grow up in a wealthy family, I was the first person to graduate high school in my family. If we wanted to go to the doctor, it was free. If we wanted to get antibiotics, if you were considered low income, it was free. If you weren't, and you spent over a certain amount of time, if you'd spent more than $100 or $200 in a year, all your antibiotics were for $2. And that sort of stuff is... The other thing that's really different in Australia is there's no pharmaceutical advertising here. So they can't advertise for a vaccine, they can't advertise for an antibiotic, they can't advertise for anything like that. So I think that actually also plays a role in it. But alternative health practitioners are also contributing to this. There's a condition called chronic Lyme disease, for which there is no evidence it exists. Lyme disease exists. It's caused by, I think, a tick bite, and it gets treated. Chronic Lyme disease doesn't really exist, but their method of treating it is to put people on high doses of antibiotics for years. And that sort of thing, you can imagine, is, even though it's a small group of people, you're going to create some super bugs in people that are on antibiotics for years. Things like tuberculosis, they have to be for long periods of time because the particular bacteria is very resistant to them, but over time it will actually kill the bacteria. You can measure that it's dying, and you can see people get better, whereas this chronic Lyme disease and other things that use high-dose antibiotics as a complementary and alternative medicine, because for some reason you can get away with it, whereas in Australia there's no way it could be. Any doctor who's doing it would be investigated. It's just beyond me. But yeah, the fact that you can't go to the doctor really angers me and most of the people from the UK as well, because they have free medicine. They're trying to introduce a charge to go to the doctor here in Australia of $7. And if the government has tried to introduce it and it's not going to get passed, and if it gets passed at the next election, they will be wiped out.
Mm-hmm.
And the party that comes in will remove it, and everyone will be happy, because it is it's considered almost one of the best things about Australia, is that you might not get to choose the exact doctor, but you get to choose which clinic. You can go to anyone that has this sort of what they call bulk billing, and a lot of doctors will, if you've got the money, they'll charge you $22 a visit. If you don't, it's free. And that's the thing, is free medical care is always available. And I think that's incredibly important for healthcare, both immediate and also long term, so that you don't have to rely on Mexican drugs. Although I've heard that can be quite fun.
Or Canadian drugs. I think it depends on what part of the United States you're in. I know people that run for the border in Canada, or have heard of, I should say.
I saw the Michael Moore documentary when people had to get...
This is a whole other thing. I think all three of us could probably rant on just how pathetic America's healthcare system is and how expensive it is. But instead, let's go back to talking about viral therapy. And you had already said this before. The question I have are, what are the dangers of using viral therapy or viral vectors? And you talked about the danger of cancer. Are there any other dangers?
Okay, so there's a really good site at the mayoclinic.org, and they've listed everything that they think is sort of dangerous to viral vectors. And essentially there's 4 types. As I said, there's the possibility of causing a tumor or a cancer. There's an infection caused by the virus, but as I said, viral vectors are modified so that they can't cause disease. And so with the HIV-based viruses, they actually grew them in cells and split them every couple of days, and they did this for 2 months, and they never detected a single actual virus. So it's not really likely that they can actually revert back to being a dangerous virus. Targeting the wrong cells, so if you can put a virus, I was talking about the lung, if you inhale a virus and then suddenly it gets to your kidney, that could obviously be a bad thing, but generally what happens is we inject doses of viruses, and you're looking at less than 1 mil. That's 1/28th of an ounce in American, into different areas, so there's not actually a lot of virus floating around. It's not like you get an IV. And then they're saying an unwanted immune system reaction, which is basically your body's immune system may see these viral vectors as virus and attack them, and it can cause inflammation, and in certainly you might get that. But most of these viral vectors we started off with sort of all the viruses, and it's sort of gradually narrowed down to certain viruses because they don't elicit a huge immune response. Because obviously if you want to treat epilepsy in the brain and you want to target certain areas of the brain, you don't want your brain inflamed. That's sort of something we can all agree on. Brain inflammation is a bad thing. There possibly will be a minor immune response, like getting a vaccine, you often get sore or red arm at the site of injection. And that's the sort of thing that, as long as it's sort of localized to the injection site, then you're probably okay. I mean, this Glybera, which is in Europe, they actually give it into your muscle, and they give a serious injection to your muscles, and that's it. That's all the treatment. So they're the gene therapy risks, and I can forward you that link, or I can tweet about it later. So if anyone wants to have a look for themselves,
that would be great if you could do that. And then, you already answered this question. Will you also get sick from the virus if you're being treated with viral therapy? You already answered that. The last question I asked you that I wanted to ask you is about pushback from uninformed parts of the community. Like we see the anti-vaxxers, they're anti-vaccine, and these people are largely uninformed about what a vaccine really is, or they're getting fed misinformation. Are we going to see, or have we seen, that happening with these viral vectors?
Yeah, I guess as you'll aware, and probably most of viewers would if they've even listened to me on Twitter for 5 minutes, is I do a lot of campaigning for vaccination. I think with vaccination, because it's something given to everybody, there's a lot of some people push back. And in Australia, unlike in certain parts of the US, it's not compulsory. And I think that has taken the sting out of a lot of the Australian anti-vaccination movement, because people can go, I'm scared of vaccines, I don't want to have a vaccine, and you have to sign a form and that's it. They don't kick you out of school. There's nothing like that. And so with a viral vector, it's a treatment. And so if someone goes, I've got cancer and I want to refuse chemotherapy, we kind of go, sure. If you're an adult, you're of sound mind, that's your choice. And they can go, well, we want to refuse viral vectors. And we go, sure, you're an adult, that's your choice. And I think that's the difference, is these will be a treatment offered to someone versus something that is considered the norm. I think the thing is, some people might, I think the biggest problem we'll have is The Walking Dead. I think when you talk about viruses, the majority of people, when I search for viruses when I'm writing articles, the amount of people that come up with zombie movies is phenomenal. I've never created a zombie. I have no intention of creating a zombie. However, if I do create a zombie, I'm pretty sure that it will become world news and I'll be famous. So I think people are worried about, and you talk about agriculture earlier in terms of antibiotics, but I think genetically modified foods is something that people get antsy about quite a lot, with introducing different genes into different plants. And I'm certainly not going to go into that today, but the difference is, with a viral therapy, you're introducing a human gene into a person that lacks a human gene. So it's actually, you're introducing pretty much the correct form of their own DNA. In terms of targeting bacteria and things like that, then what you'd be doing is probably more of a grey area for people. But again, I think it's a little bit further off, and I think we'll have a much better body of literature, because, as I said, the first one is available in a clinic, not a clinical trial, in the last couple of months. And so this is sort of an evolving field, and I think within 5 years, when you've got people who have got genetic diseases who can sort of say, actually, I had one dose of this viral vector and my life expectancy went up 25 years overnight, it's going to provide a fairly good emotive thing. And the other thing is, with vaccines, you're giving something to someone who's healthy to prevent something they don't know will ever get. Whereas if you've got someone who's ill, people kind of go, well, I'm sick. If you give me something to make me better, I can see cause and effect, and I have less issues with that. But we have, as I said, there's people who will rail against anything for a variety of reasons, and the Bible doesn't mention viral vectors. I've checked. So there will people who will argue that we're playing God and that we weren't meant to do this. But again, they argue that evolution doesn't exist, which kind of, the antibiotic resistance thing actually conclusively proves that these bacteria are evolving. So just, yeah, it's the godless family resource. I figure I should get a little bit of something.
Well, I feel like the same could be said with traditional medicine, like antibiotics, is that you're playing God if you don't let the disease consume you like he intended, regardless of what type of therapy you use. So their argument's going to be the same no matter how many new developments you have.
Right.
I mean, in biblical ages, we've never come across evidence of a 600 or 900-year-old person. So the evidence seems to suggest that the average life expectancy was well under 40. Whereas in Australia, it's recently come out. My son was born 8 months ago, and he's expected to live to, I think, he's 89. So that's also all pretty much happened in the last 150 years, and that's not because we're eating better food. It's not because of anything other than medicine and being able to treat that. So if you want to die at under 40, then again, as long as you're not hurting anyone else, I don't really have any issues with you refusing medicine or blood transfusions. That's completely your call, and I actually feel really strongly that you should be able to refuse any sort of medications, but that's your choice. When you start trying to force your views onto someone else, like I think Subway in the UK has now removed pork products, and And it's like, well, if you don't want to eat pork, that's great, but when you will take my bacon away from my cold, dead, greasy hand.
Yeah, I thought that was pretty ridiculous. Like, cab driver. Like, I was reading somewhere that a cab driver refused to drive a lady because she had pork in her bag, and this was in the I believe in the UK as well. And it's just like, come on, really? She's not asking you to eat the damn pork. Why can't you drive her where she needs to go? You're in the UK. People eat pork in the UK.
Well, yeah,
know where
in the
you're
UK,
at.
it's I'm hoping that a Jewish driver will not have to ask whether I'm circumcised before I get a lift, because that's just going to be quite uncomfortable at the airport. And so there's that sort of thing. And with medicine, I think that, you know, if you refuse something because you don't want to be treated, that's completely your call, and I don't really care about that. Vaccination's different because it's herd immunity. It does affect other members of the community. But in terms of, if you've got a genetic disease and you think that that is given to you by your or a god and it's your burden to suffer, then yeah, that, you know, I'm certainly not going to force you to take anything.
So I have
I'd
a
also
question.
like to point it.
Oh,
Before
sorry,
I go,
go ahead.
I always put this in. I am a PhD scientist. I'm not a medical doctor, so I'm giving you information based on the scientific research. Nothing I've said is medical advice. So if you do have any questions about your own personal medical stuff, please go and see an MD.
You can't look at this rash I have really quick and just tell me what it is.
I can look at it and I can poke fun at it, but I'm probably not going to give you anything useful.
Okay. We're running short on time, but I do have one last question just based on the article that I was reading. I don't know if you can kind of hypothesize more about the future of viral vectors, but evidently it says that the Supreme Court in the United States just passed a law stating that naturally occurring genes can't be patented. And so when it comes to big pharmaceuticals picking up on these treatments, or in essence not being able to...
meeting is about to commence in the auditorium. Thank you.
Sorry, we were just getting an announcement.
That's okay. But
Yeah, I'm
pharmaceutical...
just taking a break from actually making some viruses today. So yeah.
Okay.
So in terms of big pharmaceuticals and patented genes and things like that, the gene itself is purely the device. The viral vector itself is probably what they'll patent, and so they'll patent it, they'll develop the viral vector, they'll get all the safety on it, and then to actually put in, like, so 90% of their costs will probably be getting the viral vector itself, like the machinery, approved and made safe, and then to add another gene will be not much cost. But as I said, the one treatment with the one that's available in Europe is $1.6 million. So, because it's one treatment. So they can, as I said, if I start on a Monday and I've got the material, by the following Friday I can have a viral vector ready to inject. So it's very quick, it's very easy, and it's incredibly cheap. And if you've already got patented viral technologies and you change one gene in, it doesn't matter whether you've got that gene patented or not, because the actual delivery mechanism is where you will actually have your IP and all that sort of, and because pharmaceutical companies, I'm not necessarily a big fan, but I don't think they're stupid. And so you imagine that they're kind of going, all right, what we'll do is cystic fibrosis, there's, 1 in 2,500 people in Australia have cystic fibrosis. That's a good option because, 25 million people, you're looking at, quite a lot of people who have it, 100,000 people if my maths is vaguely correct, 10,000 people. And you can do that, and then that can be given anywhere in the world. Then you look at other diseases. I think when you get the disease of which is 1 in 50 million people, it will be more difficult. But I think you'll actually get to a point where people will be able to order them. You'll have a rare disease which only affects, say, 200 people in the world, and they just need to have this one gene delivered. They will be able to say, the company will go, all right, well, it will cost us $6 million to get all the approvals to create this, and if you raise the $6 million, we'll do it. And I think that has the ability, whereas a pharmaceutical drug will cost millions and millions and millions and millions and millions. And so they're more broad, whereas a viral vector can be targeted. And it can also be individually targeted to a particular person or a particular subtype of cell. So I think that it's going to be opening up, and hand in hand with the more personalised medicine of which people are actually going towards. So yeah, I think pharmaceutical companies will still make an absolute packet of it, and it will be more appealing to them because they're only going to have to change 10% each time rather than reinvent the wheel, which is what they have to do with pretty much every new class of antibiotics.
Right. Yeah, I was wondering if there was a way that they could capitalize on that, because it seems like if they can't and it just ends up being this treatment that isn't widely available, even though it's really effective, people could go to the doctor and the doctor say, I have this great treatment for you. It's $500,000, but it could save your life. So I was hoping that there would be a way that they could capitalize on that so that they become widely available for people.
Yeah, I think that's definitely, and as I said, the current treatment is the first in the world, and it's $1.6 million for the treatment that will change your life forever. So if you get it at 20, this should last you out. So you kind of go, well, $1.6 million, that's a lot, and that's the first. It's going to come down. If it goes down to $160,000, so 10%, that will mean you don't have cystic fibrosis and your life expectancy goes up 25 years. You're kind of going, $160,000 is suddenly, it's expensive, but it's, and a government, like as I said, Australia's got socialised medicine. So if a government goes, okay, it costs us $10,000 to treat someone with cystic fibrosis per year, $160,000 by year 17, they're not getting treated, they'll actually save their money. It becomes an economic thing for them. And so I don't understand how the States works, but with places like the UK and a lot of European countries where the government does actually pay for treatment of certain chronic diseases, they can essentially cure that disease. The money they will save, and that's what we do. That's why we vaccinate. We vaccinate because if you vaccinate with HPV, every year that somebody is treated for cervical cancer, I think is $23,000 minimum. Whereas you get a vaccine which might cost your government $300. You can treat a lot of people before it becomes more expensive than the cancer treatment. So, yeah, so I think economically, which is how you've got to look at these things, it will be very attractive.
Excellent.
Sorry.
Okay, you're muted. Hello.
There's so much noise happening. Children are getting up and walking around. They're supposed to be asleep. So, sorry about that. Anything else you want to say before we go, Dave?
Just that all of these things are developing technologies, and you think about computers and how they develop and how things change, and how we learn that, certain things fall out of whack, certain things become more popular. Like, I don't imagine anyone's looking at this on Internet Explorer, but it's the same with medical treatments. We'll start with a much, a broader, and then we'll narrow it down to what actually works, and that sort of goes from cells through animals to clinical trials to, once something's in the clinic, we don't stop analysing it. We use sort of post-marketing surveillance. So you can bet that every single person that gets this viral vector will be analysed to within an inch of their life for the next 5 or 10 years. And this is how we will improve it. So everything I'm saying now is this is the state of play at the moment. There could be a revelation that comes out tomorrow that is a game changer. Either it shows that something else is safer or more effective, or it shows that something has a risk we didn't know about. So it's such an amazing and interesting field to actually be working in that I feel really lucky that, I'm making a viral vector today that no one has ever made before. And I don't know a lot of people who get to do something that no human has ever done before on a pretty much a daily basis. So I love my job. I'm on Twitter at Mr. Hawkes, MrHawkes. So I've written a few articles about viral vectors, and I'm more than happy to answer any questions anyone has, or just talk about viruses in general because they're kind of awesome. Bacteria, yeah, but viruses are definitely something I find just beautiful and elegant and so simplistic that we've spent, HIV I worked on for 5 years. We've spent 30 years of the best minds in the world and billions of dollars, and we can kind of hold it at bay, and that's where we've got in 30 years for something that has less DNA than one of your genes, and yet it's defeating us. So there's elegance in the brutality of it.
Okay, thank you, and thank you for being on the show again. We love having you. We learn so much.
Definitely.
Sorry, the new time works better for me because I'm off to lunch rather than last time when I was at 6 a.m. in the morning in my spare bedroom feeling fairly bleary-eyed. So
Yeah.
I'm at least out of my pajamas this time.
Definitely.
Amanda, anything you want to say or promote before we go?
Yeah, my blog, as always, humanistmom.com. And then, of course, ProfitCast. That's on Sundays at 9:30. Next week, I'll actually be on the show with Mama Atheist, who's pretty prominent in the atheist community. I imagine since she's Mama Atheist, we will be talking about secular parenting in some way or another. So I'm really excited about that show. Yeah, that's it.
Okay, great. And as usual, I would love for you to check out godlessfamily.com, check out all the resources, check out past episodes of the webcast, and follow us on Twitter. And next week, Amanda, who do we have?
Oh, right. Yes. So our guest next week is Courtney Lynn, who is an author of children's books about atheism, free thinking, and science. So we are going to talk to her about her books and some of the experiences she's had as a secular parent and as having a child who kind of identifies as agnostic or atheist.
All right, awesome. So hopefully we'll see everyone next week. And once again, thank you, Dave, for coming on the show again. We love having you.
Thanks for having me. It was great.
Bye, everyone.